Howdy folks, welcome back to the VGI module. In this last video in the module, we're going to cover our final learning objective, which is being able to use VGI in your apps, websites, and other systems. Now this video is targeted at those of you who have opted into the technical track, but there's also information in it that's going to be interesting to those of you in the concepts and the curiosity tracks. So while this material will not be on the concept track problem set, it still is probably worth watching for those of you in the concept and the curiosity track. Now the type of VGI we're going to focus on in this video, and the type of VGI technical tracks we'll be working with in their assignment, is Wikipedia VGI. Now we've already talked a bit about the impact Wikipedia VGI has had, not only on spatial computing, but also on computing in general. However, I want to crystallize this impact a bit for you here before you learn about how to work with Wikipedia VGI, so that you have a full understanding of the power you'll have at your fingertips once you do. Now, in general, Wikipedia and Wikipedia VGI has revolutionized computing in not one, but two separate ways. The first way is well known, right? Wikipedia is just a very popular means by which people get encyclopedic information. More specifically, Wikipedia is the sixth most popular website in the entire world. It receives more monthly visitors than WordPress, Twitter, and LinkedIn combined, and there's some research that suggests that Wikipedia is the #1 result for around 50% of searches on Google and Bing. Now, the second way Wikipedia and Wikipedia VGI have changed the computing world is that they have become an extremely important source of information for thousands of modern algorithms and technologies in computer science and related fields. In some ways, I really don't think it's a stretch to say that Wikipedia has become the brains of modern computing. And that is why we called our Wikipedia software library, which allows programmers to easily build Wikipedia and Wikipedia VGI-based applications, WikiBrain. Now in this week's assignment, you'll be learning the basics of how to use WikiBrain to build Wikipedia VGI-based applications, so that you too can have the tools to begin to participate in this Wikipedia-fueled spatial computing revolution. Now, WikiBrain is a collaboration between the Math, Computer Science, and Statistics departments at Macalester College in St. Paul and my lab, Group Lens Research, here at the University of Minnesota. Our main collaborator at Macalester College and the leader of WikiBrain development is Dr. Shalad Sen, and you can see him here with the rest of the Macalester WikiBrain team in this picture. Now, as I mentioned, WikiBrain was built to make it easier for practitioners and researchers to take advantage of Wikipedia data, including Wikipedia VGI, to make their applications smarter. Now, more formally, our mission with WikiBrain is to democratize access to Wikipedia data and state-of-the-art Wikipedia-based algorithms and technologies. For now, our audience is folks with Java skills, although we hope to provide APIs for Python and perhaps PHP in the near future, but after this MOOC ends. The current focus of WikiBrain is on providing access to core Wikipedia data structures, to well-known Wikipedia-based artificial intelligence and natural language processing algorithms, and to the spatial data in Wikipedia, or Wikipedia's VGI. And then finally, our design goals for WikiBrain are that it be very easy, very flexible, very fast, and very extensible. Now, all of this will become more and more clear as you do your assignment this week. I'm now going to turn things over to Toby Lee, my research assistant and one of the TAs for this course. You've probably seen him in the forum. And he's going to give you a quick intro to programming with WikiBrain, and he's going to briefly describe your programming assignment.
Hello folks, I'm Toby Lee. I'm a research assistant at University of Minnesota. I'm also your TA for this course. My research area are VGI analysis and spatialization technologies. It's so nice to have the chance to meet you guys in the video. Hope all of you have enjoyed the course so far. Today, I'll show you guys how to set up our virtual machine image, which contains a required programming environment for our programming assignment. I will also walk through an example we provided that contains all the basic queries you'll need for the assignment. We provide you the virtual machine so you don't have to spend hours setting up the environment. Instead, you can pretty much start programming right away after downloading the VM image. VM is a sandbox, so don't need to worry about what you do inside the VM will harm on your file outside. The VM is a pretty big file, it's like 2 GB, so I'll suggest you start downloading the file early. First, you'll need an Oracle VirtualBox. It's available on their website. You can just Google it, do VirtualBox, and here it is. Go to Downloads. You can see it's available on many platforms, including Windows, Mac, and Linux, so you can just download whatever works for you. I already have VirtualBox on my machine, so I'll just go ahead and open it. For the new, and you should choose a new virtual machine and name it whatever you like. I'll do spatial computing, MOOC. For type, you should choose Linux, and for the version, you should do Ubuntu 64-bit. Continue. And then you should choose memory size. You should do at least 1 gig, but I would recommend you 2 gigs in case it uses more memory. But we've tested on 1 gig and it works fine. And for the hard drive, you should use an existing virtual hard drive file, and you should navigate to the VM image we provided, which is here. And you create. Here it is, and you do start. It takes like 30 seconds, 60 seconds to start it up. And for login screen, both the username and passwords are spatial, in lowercase. So now you are at the VM. You can see we have everything already installed for you. We have Wikibrin, we have TileMill, we have the IntelliJ, which is a Java IDE, and we have all the environment like JDK, Maven, Postgres, PostGIS, and stuff. So you guys don't have to install them on your own machine. For the Wikibrin assignment, we will use IntelliJ as an example IDE. You are welcome to install any other IDEs or editors you like. So you just click the button, the icon on the desktop, and do execute. Okay, now you are at Wikibrin. You can look at it. We got the code, we got the project structure coming up here. For you to get familiar with basic queries in Wikibrin, we provide you an example program. The program is located at the Wikibrin codebook module, source, main, Java, Wikibrin, codebook, and go to mooc. It's called queryexample.java. In this file, we provided many basic queries so you can get familiar with Wikibrin stuff, and all the queries we cover here, it should be enough for you to get through the program assignment. So you can see the part 0 are basically setting up the environment and initialize the DAOs, data accessing objects, and configurations. You don't really have to understand those, but you need to remember, you need to copy those parts of the file to every single Java file you write for your program assignment. And for part 1, we have a very basic task, which is getting a Wikipedia page by its title. You can see we use a local page DAO, get by title, and we choose a language to be simple. Simple means simple English Wikipedia. It's right over here. It's a Wikipedia edition that is written primarily for English learners. It uses like basic grammar and words, and it has much less data, which is great for our purpose because we don't want you to spend days to download the full English data. You're welcome to do so if you like, and if you have 1 terabyte of space or so. Okay, let's get back to the IntelliJ. You can see for the first part, we get a local page and we just print it out and go ahead and run that so you know how to run the stuff. You do run and you do run query example. Okay, it's running, great. You can see all results are coming out. So you can see for part 1, we got a local page object, which is University of Minnesota. That's what part 1 does here. And part 2, you can see we try to resolve a phrase to a Wikipedia page. In this case, we do Georgia, because you guys know when I say Georgia, it could mean the US state Georgia or the country Georgia, and there is no way you can know about it. But on Wikipedia, we can try to resolve it and see like whether it's more possible it's a US state Georgia or it's a country Georgia. For part 2, you can see according to the anchor text, which I'm not going to explain here, there is a 65% chance that when you say Georgia on Wikipedia, it means Georgia, the US state. And there is like 1/3 possibility that you mean Georgia, the country. That's how you can, let's say, resolve a phrase to a Wikipedia entity. There are many more examples out there, and I'm not going to go through all of them. They are pretty good commented, so you guys can just go through them by yourself and see what it does. And yeah, with all the queries, you guys should have no problem working on the program assignment. Okay, now let's look at the assignment. The core idea behind this assignment was to have you guys play with Wikipedia a little bit so you can practice how can you process and analyze large VGI. Before you start, you should make sure you've set up the program environment and you are able to successfully run the example program I just went through. I also recommend you to read the paper Wikibrain Democratizing Computation on Wikipedia because it provides a better context why Wikibrain is built, how it makes analyzing Wikipedia much easier than before. The first part of this assignment is the warm-ups, where you can execute basic spatial queries. If you have any problem like writing the program, you should always go back to the example queries and you can find some similar queries and you learn how to use those features. That should help you a lot doing the program assignment. And for the second one, we focus on semantic relatedness, which is a topic we will cover on Module 6, but we will have a head start here. SR is a metric that assesses a number of strengths between relationships. Like for any two concepts, it will produce a value between 0 and 1. The higher the value is, that means the two concepts are more related. And for the third question, we focus on the in-degree sum, which is a metric that measures the importance and the quality of Wikipedia articles. For given area, we add the number of innings of each article up. And the more inning we have, that means this area is more important and more will cover on Wikipedia. Like let's say, if we have an article that has a lot of links pointing to it, it's intuitive to think that this article is important because many stuff linked to it. It's a very important metric for the importance of place and the amount of information available. So for this one, you just check the in-degree sum and on the US states and see which one is more important. Hope you guys can all enjoy this program assignment. I personally invite you to stay around and find more interesting stuff in Wikipedia using Wikibrain. After completing the assignment, remember to share what you found in the forum. If you have any questions, don't hesitate to post in the forum. For those of you who are able to complete the assignment early, it will be really great if you can help your peers in the forum. Enjoy!